For problem 2, first according to the message, and we can plot the feasible region of the density function of x and y, and it's like this. The shaded area is the feasible region of joint function x and y, so that we should pay attention that when y is greater than 0, the joint density function is like this, and when y is less than 0, the joint function is like this. So the method to solve this problem is we deal with y greater than 0 and y less than 0 separately, and then we sum them, these two parts together, and if it is a valid probability density function, it should satisfy this equation according to the definition, so that in this case we can rewrite this part into this part according to the joint density function of x and y, and so that after some steps we can know that a equals 3/2. And the same questions, because z equals x multiply y, so that we have two conditions. The first is that when y is greater than 0, and because x is always greater than 0, so that z is greater than 0, and as a result we can plot the feasible region. And but we should pay attention that when z is greater than 1, the diagram of z equals x multiply y is this part, and it has no intersection with the feasible region, so that if z should equals 0, and when z is greater than 0 and less than 1, the feasible region is this shaded area. So that we cut this part into two different parts. So one is from 0 to this one, and one is from another is from this to 1, so that we can know that the distribution function of z equals the sum of these two parts, and we can know that after some steps we can know the distribution function of z equals this part, and according to the definition we can work out the density function of z, which equals this one. And when y is less than 0, because x is always greater than 0, so z is less than 0, so that the feasible area should be in part 4. And we know that when z is less than -1, the diagram of z equals x multiply y is like this, so there are no intersection with the feasible area, so it equals 0. And when z is greater than 1 and less than 0, it should be like this, so the feasible area is just this shaded area. So we also split this part, this shaded area into two parts. One is this, and another is this, so that we can know that the distribution function of z equals the sum of these two parts, and after some calculations we can know if capital Fz equals this one, and according to the definition we can find out the distribution density function of z equals this part when z is less than 0. So these two equations are the answers to this problem.